We're going to look at a new way to integrate called using partial fractions. And this is something you should have seen earlier in one of your math classes, but we're going to review the method as well as deal with some more complex situations. So we have 1 over x squared minus 5x plus 6. And that's possible to integrate sometimes, but it's very difficult. The right-hand side, if we were to able to write this as two fractions, as the two fractions that were added together to give us the left-hand side, it's much easier to integrate this because these denominators are going to be linear factors. So what we want to do is we want the factored form for x squared minus 5x plus 6. And those factors are going to be the denominator of the right-hand side. So we're going to have x minus 2 and x minus 3. And just like if I had 3/8, let me pick a different one. 5/8 is the same thing as 1/4 plus bad example. 1/4 plus 1/2 is the same thing as 6/8. These factors of 8 make up the previous two denominators. Now we just have to figure out what goes on top. What are the numbers that go up here? And what we do to find these things is we're going to multiply by the common denominator. And what that will leave us with is 1 equals a times x minus 3 plus b times x minus 2. To find a and b, we're going to pick two values of x, because this is always true for all values of x, but I'm going to pick two special ones. I'm going to pick let x equals 3 and x equal 2. Because those will make these factors equal to 0. And when I do that, I get 1 equals, the a term drops out, and I get b times one. So b has to be 1. That's nice. Now I let x equal 2, because that will make the b term drop out. 1 equals a times -1. A is going to be -1. So this original fraction can be written as -1 over x minus 2 plus 1 over x minus 3. And if we were to get a common denominator, we could add these fractions together and you would see that we do indeed end up with this first fraction. And you can see that these two terms are going to integrate nicely. They would both involve a natural log. So if I threw an integral in here, this would just be negative natural log of x minus 2 plus the natural log of x minus 3 plus c. Now let's amp this up a little bit. Now we don't have just a nice constant on top, and we don't have a nice quadratic on the bottom. We're still going to look at the factorized form of the bottom, and the bottom factors into x times x plus 1 times x plus 1. In other words, x times x plus 1 squared. And when we do this, we're going to set this up as a over x plus b over x plus 1. And then because there's a factor repeated, we're not going to put c over x plus 1 again. We're going to put c over x plus 1 quantity squared. Now remember, to clear out these fractions, we multiply by the common denominator. And this is the equation that we're left with. And now we're going to pick special values of x. We're going to let equal negative 1 first, maybe. X equals negative 1. And we plug that in. When we plug in x equals negative 1, we end up with negative 9 equals, and then on the right hand side, the b and the c, or the a and the b term go away, and I'm left with c times negative 1. So c is equal to 9. And then I can let x equal 0. And the left-hand side becomes 6 equals, the b and the c term go away. I'm left with 6 equals 1a. So a is 6. So I have a, I have c, I still need b. And what you might be saying here is, there's no other values of x that make the factors equal to 0 on the right hand side. I can't get any of these other terms to drop out. But since there's only one other thing that I need to know, I can pick any other value of x, and it really doesn't matter what. I'm going to pick a small one, an easy one for me to plug in, say x equals 1. And when I do that and plug it into the blue equation down here, I end up with 31 equals 24 plus 2b plus 9. So 2b has to equal negative 4. b is negative 2. And here's what I now know. I now know that I can rewrite this integral as 3 separate integrals. The integral of 6 over x dx minus the integral of 2 over x plus 1 dx plus the integral of 9 over x plus 1 squared dx. And these are all simple integrals to find. Six times the natural log of x minus 2 times the natural log of x plus 1 plus 9 times the natural log of x, not the natural log. Got stuck in the pattern there. This is really 9 times x plus 1 to the negative 2. So when we integrate that, we get minus 9 over x plus 1 and then plus c. And I suppose one thing that I am forgetting here is that when you integrate and get the natural log, it should be the natural log of the absolute value of that thing, because we can't take the natural log of a negative number. And I'm missing that from my first problem too. And time to make this problem more difficult yet. Again, we're going to try to split this up into multiple fractions that have denominators that are factors of the original. So make sure everything's factored up here. And notice that x squared plus 4 does not factor. It stays quadratic. That's as good as it can get. I'm going to have a over x plus b over x minus 1 plus something over x squared plus 4. But since x squared plus 4 is not a linear factor, it's a quadratic factor, the numerator needs to be linear. It's going to be cx plus d. And now, just like before, I multiply by my LCD. And we look at what happens. So here we go. What two values of x will we be able to plug in here to make different factors of this 0? We're going to let x equal 1 and let x equal 0. When x equals 1, the a and the cx plus d terms go away. And what I'm left with is negative 10 equals 5 times b. So b has to be negative 2. When I let x equal 0, what I'm left with is negative 8 equals the b and the cx plus d term go away, and negative 8 equals negative 4a. So a has to be 2. And now I'm stuck. There are no other values of x that I can plug in that make factors go away. I still need to know what c and d are. So what I do is I pick any two values for x. I have two unknowns, I need two equations. So far, before I get into that, I'm left with 2 over x dx minus the integral of 2 over x minus 1 dx, and then I'm going to have some other integral at the end here that's over x squared plus 4. Let's find out what that is. So I'm going to pick any two values of x, and doesn't matter which ones. I'm going to plug in x equals 2, and I'm going to plug in x equals negative 1, keeping the numbers small. When I plug in x equals 2, I get 0 equals, now I know what a is. A was 2, and b was negative 2. So by plugging in x equals 2, I'm left with only c and d. But I get 16 minus 32 plus 4c plus 2d. And I can move my constants to one side, and then everything's divisible by 2, and I'm left with 8 equals 2c plus d. When I plug in x equals -1, I'm left with -6 equals -20 plus 10 minus 2c plus 2d. And that equation reduces down to give me 2 equals -c plus d. Now I have a system of two equations with two unknowns. We know how to solve that. And this one's pretty straightforward. If I just subtract the two equations, c is 3, therefore d has to be, once I substitute back in, 2. So c is 3, d is 2. So 3x plus 2 is my final numerator. Now we need to integrate. The first two integrals are fairly straightforward to compute. To find, we have 2 times the natural log of x minus 2 times the natural log of x minus 1. Now this last one looks a little hairy, and you might look at it and say, gosh, I can't do that. Well, that one just needs to be split apart into two separate fractions. It's going to be the integral of 3x over x squared plus 4 plus the integral of 2 over x squared plus 4. And then depending on what you like to do, I can change this into the natural log of x squared, getting rid of the absolute value lines. Same with the second term, I can move the 2 up there. Plus, now I need to do a little u substitution with this first integral in blue here. If u is 3x plus is x squared plus 4, du is 2x dx, but I have 3x. So what I need is a 2/3 here out in front. And this is going to change me so that I have a natural log again. 2/3 times the natural log of x squared plus 4 and then the last integral fits the pattern for arctangent. It's 1/2 arctangent of x over 2. And then 2 times 1/2, those just cancel. And really, we could go a bit further. As these are a bunch of natural logs, we can combine them together using properties of logs. We end up with That's just combining these three logarithms together using sum and difference properties for logs. And really, you'd probably be okay stopping right there. One note before you start the assignment, and that is if the numerator, typo there, has a degree that's higher than the denominator, you have to perform division, long division probably, and write out what that quotient is. So probably some polynomial plus a fraction where the numerator is less degree than the denominator, and then you can find your partial fractions. So your assignment is on the worksheet. It's section 8.6, I believe. You should have it in your packet, and these are the problems that I would like you to do.